Ready, teacher.
Okay, okay. So we're ready. I am recording already. So, okay. This is the example number 7, which we have done last time, but with the use of the modification and symmetry. So let's say if you want to do this one and you don't want to expand your understanding to take advantage of symmetry and simple end support, you may end up with a lot of work. So let's try to show you what will happen if you don't utilize that and if you do, okay? Oh, here we go again. So I think we all know by now that, let's say if I call the support A, B, C, D, E. Now we have 5 supports, meaning we have 5 unknowns, right? And maybe it's not a bad idea to always write your unknown. So your unknowns will be theta A, theta B, theta C, theta D, and theta E. Okay, 5 unknowns. And I'm going to skip some process. And then we are going to go to the SD equation right away. Okay, now because if you don't take advantage of anything, it means that you are going to have to write down MAB, QE. I sort of remember that this is 1K, right? And when you don't take advantage, you know you're going to have to include theta A. Okay, now remember I keep saying this and I'll keep saying it, hoping that this will get to you guys. Hey, theta A is not 0. Okay, theta A is never 0. Not 0. Never. So when you don't take advantage of the simple n, you need to solve it. And then you have MBA, H2E, K, let me write this way, theta A plus 2 theta B, okay, plus F E M B A, okay, and then M B C, 2E, 4K, 2 theta B, plus theta C, plus F E M B C, MCB, 2E, 4K, that's a second span, right? And then theta B, theta C plus 2 theta B plus FEMCB. And then, of course, you can see the symmetry now. Now it begins to break, because first you can see that if you don't utilize a simple n, you will use the simple equation here. Okay, and then if you don't utilize the symmetry, you will start writing something that will say, it's a repetition of what you have done before in the first 2 spans. So you have MCD, 2E, 4K, 2 theta C plus theta D plus FEMCD. So my apologies to those of you who got this, but it doesn't hurt to listen to it again. Just make sure that you get everything covered, okay? This 4K and theta C plus 2 theta D plus FEMDC.
Teacher ครับ
Yes.
พอ MCB อ่ะ 2 theta C หรือเปล่าครับ
Yeah, right. Thank you. Yeah, that happens. Thanks a lot. Okay, and it's not that easy writing here. We have 2 zeta c, and then we have, okay, let's be consistent. Let me erase this. All right, and this we have 2 zeta d plus zeta c, and then m de, right? 2 e k 2 zeta d plus zeta e plus f e m d e, and again m e d 2 e k 2 zeta e plus zeta d plus f e m e d. So you see the work here, the red one, this is completely unnecessary. But if you want to be engineer who works hard all the time, you don't want to be an engineer who works smart, this is what's going to happen to you. Okay. And now we back to the, here we go again. Suppose if I'm going to scroll, it's going to have to be like, yeah, right there. So here we are. The next step is the equilibrium equation. And because you don't take advantage of that, you're going to have to write sigma MA equal to 0. And sigma MA equal to 0, it means because at A we only have MAB, right? So basically it's that equation. MAB equal to 0 and then equal to that one. See? So you're going to have to, you know, do something that you don't need to. 4 EK zeta A, right? Plus 2 EK zeta B plus F E M A B and sigma MB equal to 0. This time it's MBA and BC, right? So I have how many? 4 and okay. Sigma MB is MBA and BC, right? So I have, let's write down MBA plus MBC equal to 0. And then you have, for A, we have 2 EK zeta A. For zeta B, we have 4 and 4, that's 16. So 4 and 16, that's 20, right? Am I right? EK zeta B. And then plus oh, you know what? It's too much. It's 1 zeta B, right? Okay. So we have 8 EK zeta C plus FEM, you know, I'm running out of space. And then you're gonna, if you don't take advantage of symmetry, you're gonna have your sigma MC now. Sigma MC equal to 0. It's gonna show up. And this is MCB plus MCD equal to 0. So it's these two, right? And that means how much do we have? We have, hang on. We have 8 EK zeta B. Am I right? And for zeta C, we have 16 plus 16, so that's 32 EK zeta C. And then we have zeta D now. Zeta D, that's 8 EK zeta D. and past fixed end moment. Okay, so you see it's a lot of work, and then sigma md equal to 0. Yeah, and sigma md equal to 0. I'm not gonna write that anymore, but it should be something a mirror of this equation, and then sigma me equal to 0, which is a mirror of sigma ma equal to 0. Okay, so now you get me. But you need to understand that when you use a simple n and if you mean to eliminate zeta A can be eliminated, but you need the modify equation, which is, you know, the MBA is equal to 3EK, that sort of equation. Okay, when you use this one, you can forget about MAB. Okay, when you use this one, you can forget about MAB, and you can forget about zeta A. You need to be able to do this, okay, to try to go for, you know, the juggernaut and solve every unknown and refuse to understand the shortcut. Well, you know, you're not going to prosper very long. Okay, let's say if you don't do anything, you end up with the egg on the face, because 5 unknowns and 5 equations. I don't think a typical calculator can take care of this. Am I right? Your calculator is able to take the equilibrium, I mean the simultaneous equations up to 3, right? So if you take advantage of the situation properly, you will have the calculator to handle it. If you don't, you will resort yourself to using the matrix, or to solve like 5 simultaneous equations. And, you know, think about some of you. I know that this is the time where, say, you know, engineering students hate math. Okay, and it's not unusual now. It was unusual in the first time, that knowing that engineering students hate math. You know, it's unbelievable. But anyway, that's another problem. You hate math, but you don't use the shortcut, so you end up solving tough math that you hate. Correct? There's no other way to solve like 5 simultaneous equations but using the matrix or something like that, which you don't like. So by refusing to understand, you know, the proper way of dealing with the situation, you run back to what you hate. So it's, you know, it's a lose-lose situation. Okay, and because things like this will come out every year, because I want you to be able to do it. Engineers should be able to take care of symmetry. So, you know, you got to be able to do it. And one more thing, what I don't understand is, you know, some may use symmetry or may not, whatever, and they solve it. They got the rotation in the end. But then when drawing the shear force and bending moment diagram, do you know what symmetry means? Symmetry means that, you know, if we're talking about this beam, there must be a line of symmetry somewhere, and it should be in the middle. Otherwise, we don't call that symmetry, correct? So right here, the line of symmetry is here. So when you fold everything about the axis of symmetry, you have one picture that just, you know, comes on top of each other perfectly. So that should be the case for shear force and bending moment diagram as well, right? So for those of you who go that far and you see that the shear force diagram on the left and on the right, they're not the same. My, oh my, you should realize that. Okay? So I hope we are doing fine with this one. So that's it, all right? So today we are going to deal with something else. Okay, this is the old one that we have done before. Now this time we are dealing with the Sidesway problem. Remember the last time that I say when you have a frame, you don't have sidesway when two of the things occur. First is your frame is sufficiently laterally braced. The second is your frame is symmetric and it is also has a symmetric loading condition. So in a case like this, for example, you see that your frame is symmetric, but the load is not, because the loading comes in like this, so the loading is not symmetric. So that means your frame is going to sway, okay? And this case is pretty simple because we only have the load that will push your frame to the side, but we don't have any load to cause a fixed moment, okay? So without further ado, you now know that your frame is going to sway, and the sway is going to look like this. You know, when you guys draw the picture, just keep in mind that if this is fixed, the rotation is 0, so you must maintain it 0, and it go to the side like this, right? And because we always say the axial deformation is negligible, that means the amount of deflection here, if you call that delta, this should be delta. Otherwise, your horizontal member will have the strain or will have the axial deformation, okay? So it's got to be the same amount right here, okay? And because, you know, this is a rigid joint and it's not a support, so it must have rotation. And generally, because it curves like this, rotation should be in this direction. Likely, you know, clockwise and oops, like that. Okay? So, first thing first, we need to identify the unknown. So let me begin by step number 0, right? So we call it step number 0. Right, I should begin with something else, but that's fine. Step number 0, unknowns. So how many unknowns do we have here? We have done that before in our very first hours, right? Well, let's give it a name. Maybe I should give it some name first. Otherwise, we cannot refer to things very conveniently. Okay. How many unknowns does this structure have? Yeah, all quiet as usual. So we have 3 unknowns, correct? That is zeta B, zeta C, and delta. Okay, we need to use the delta simply because that will give you only one unknown. If you don't use the delta, you will end up with more than unrealistic unknowns, I can say that. Okay, so delta here is part of the sway. So let's say we have the sway like this. Okay. The angle that we use to calculate the moment in slope deflection equation is this psi angle. Correct? And you can see from this picture that theta is not psi. Okay, theta is the rotation of the joint. Psi is the rotation of the member. And in this case, you can see that your psi is equal to delta over L. Okay, so we have three unknowns in this case, and you need to use the term theta to relate the unknown to the psi term in the slope deflection equation. Okay, so that's step number 0, and we move on to step number 1. Relative stiffness. But we all have I over 5, so it's okay. Okay. Step number 2 is fixed end moment. You can say none. Okay. And then step number 3, that's a slope deflection equations. Okay. Now it's, here we go. Okay, we're back in business, right? Do tell me if something unusual occurs, right? Like the screen frozen like yesterday, okay? Now, if you can recall, your slope deflection has a theta term and then the psi term. So you need to turn this delta into the psi term, okay? So right here, we have theta, psi is equal to delta over 5. Okay, so now we can write MAB. That's 2EK. 2 theta A, which is 0 because you have the fixed support, plus theta B minus 3 psi. Psi is delta over 5 and no fixed end moment. Okay, MBA 2EK 2 theta B plus theta A, which is 0 minus 3 psi. Okay, and then we move on to MBC. Generally, common mistakes can be made here. You know, when you were in structural analysis number 1 class, you would always forget that member BC could have rotation. Could have moment, and you will see that it is very evident here because when you write the slope deflection equation, MBC is 2EK 2 theta B plus theta C. Now, what about the psi term? You see, member AB should always have moment because there are always a joint rotation at both ends. But look at your frame now. You know, the sway occurs in the lateral direction like this. And you can see that the member that rotates, in this case, there are two of them, which are member AB and member CD. You can see that we have the side in this direction, correct? So that means your member AB will move like this as a reference line, and that is your side. But member BC, it remains horizontal. So there is no rotation of member BC. You see, it's very clear. So this is 0. And MCB, 2EK, 2 theta C plus theta B, and then no sine. Then we move on to MCD, 2EK, 2 theta C plus theta D, which is 0. And then again, we have the side term. And then MDC, 2EK, 2 theta D, that is 0, plus theta C minus 3 sine as usual. Okay, so at least you need to sort the unknowns first. If you can identify your unknowns correctly, it will lead you to correct slope deflection equations. If you cannot sort your unknowns, you should know that it's useless to continue to work, because your slope deflection equation will become a mess and the rest will become garbage. Okay, so what we are going to do next is the same step, that is equilibrium equations. That's step number 4. Okay, yes, that's step number 4. Equilibrium equations. Remember, we have 3 unknowns now, so we need 3 equilibrium equations. So the basic ones you can get right away, is sigma moment at support B, right, equal to 0, which is MBA plus MBC equal to 0. Okay, so we can come here and try to establish that, because I didn't write it properly. So let me try to expand it here. We have 2EK theta B minus 6 EK delta over 5, right? 6 over 5, maybe let's call that 1.2, okay? And this is 4 EK theta B minus 1.2 EK delta. And MBC, I have 4 EK theta B plus 2 EK theta C. All right, so MBA plus MBC, so that is 8 EK theta B minus plus 2 EK theta C minus 1.2 EK delta equal to 0. Okay, the second one, of course, sigma MC equal to 0, that would be MCB, might be, plus MCD equal to 0. Now this one would be quite similar to the one that we have there, but let's do it properly anyway. So you have here 4ek zeta C plus 2ek zeta B. Here we have 4ek zeta C minus 1.2 ek delta, right? So this will give me 2 ek zeta B plus 8 ek zeta C minus 1.2 ek delta E equal to 0. So these two you guys should be familiar with already, right? But we need the third one. And you should know one thing, but I bet you probably don't realize that when you have rotation as an unknown, you establish moment equation, correct? Because moment is related to rotation. So now you have the sway as the unknown. You know, delta itself is a distance. So what do you think you should have here? Okay, so what you should have here is sigma fx equal to 0. All right, so the third equation is sigma fx equal to 0. How are we going to get that? So you will have your member AB, correct? You will have your MBA. So I'm writing with the clockwise positive sign. And you have MAB. And what else do you have? Let me change the color. You will have and right. And what we need here is this. You can call it VA. I call it V or call it H. Let me try to use the proper. Let's call it H, right? Because I generally call it H, so it's better for you. HA. Oh, okay, sorry. So how do you obtain HA? Because if you have HA, it's this one, right? And the next free body diagram would be, the same, more of the same. This time it is MCD, MDC, and to complete the free, it's not really complete, because if it's a complete one, you need to have the axial force, right? But this is HD. So when you have HD here, that means you can now write your sigma fx equal to 0, right? That becomes HA plus HD minus 40 equal to 0. All right. So the third one is a bit more painful, takes longer to do it. Now, for the first time, you may hate sigma fx equal to 0, right? So, well, how do you obtain that? So to obtain HA, you need to take the moment here, right? So your HA is in fact equals MAB plus MBA divided by 5, because your member is 5 meters long, right? So your MAB is this one, and your MBA is this one. So we have 6 EK zeta B minus 2.4 EK delta, right? Am I right? 6 EK zeta B minus 2.4 EK delta over 5. Okay, and then likewise, HD is equal to MCD plus MDC divided by 5. And you know, it's the same column and the same stiffness, so you can expect the equation of HA and HD to look rather similar. It has some relationship. Right here, it's 2 EK zeta C minus 1.2 EK delta, right? So you sum them up, it's again 6 EK zeta C minus 2.4 EK delta over 5. So, you know, in the end, it's not, let's say, it's not anything new in terms of equilibrium. What you're doing here is only the sigma fx equal to 0, right? But this time, sigma fx is the construction from moment equation. So we can say, okay. Can somebody help me do the math? It's going to be awful, but that's fine. 6 over 5, that's 1 point. Oh, no. Let me do it this way. So try to do things properly. HA plus HD. I can say I can move 40 to the other side, and then now I have 6 over 5, that's 1.2 EK zeta B, and I have zeta C, that's 1.2 EK zeta C, then minus that's 2 of them, so it's 4.8 over 5 EK delta equal to 0. Okay, so I have my equation number 1 here. I have my equation number 2 here. I have my equation number 3 here. So, you know, if I put everything together so that you can see a better picture, 8b, 2c, and minus that. So we have 8 EK zeta B plus, what's that? 2, right? Okay. 2 EK zeta C minus 1.2 EK delta equal to 0. The second one is 2 EK zeta B plus 8 ek theta c minus 1.2 ek delta e equal to 0. And the last one, 1.2 ek theta b plus 1.2 ek theta c minus 4.8 over 5 ek delta equal to 40. See, the beauty of the matrix, I mean the stiffness, is that you see, oh, my apologies, do that again, right? Yeah, I keep making that mistake. Oh, here we go. That's okay. That can be green. So it has become green a little bit, but that's fine. The beauty of this is that you see that will always be equal to that. And this is equal to that. See? And that is that. Now the sign can be opposite. It depends on how you write your equilibrium equations, especially in sigma fx equal to 0. But in the end, it's just the sign may be opposite of what you assume, okay? But when you see this, you know, you are probably correct. Because this is the stiffness of, you know, the typical structure in the elastic world. So I can write 8 to 1.2 to 8 1.2 minus 1.2 minus 1.2 and then minus 4.8 over 5. This becomes ek theta b, ek theta c, ek delta. That's 0, 0, and 40. So if you have something like this, you know that, wow, you're probably correct. And then you go on and solve this, and you get ek theta b, ek theta c, and ek delta. All right. And because I just made this problem up myself, so I don't have the solution with me. I just want you to begin with a very simple example that you can see. Okay. So, all right. Is there any question? You want me to maybe stay here? Is there any question? You want me to keep sharing the screen? We are due a break. We should take a break. Oh. Hello? Hello? So, no response? No question? So I'm gonna stop the share and stop the video.